Good morning, students. In this video, we are going to discuss Coulomb's law for class 12. In the year 1786, Coulomb deduced the expression for the force between the two stationary point charges in vacuum or a free space. Consider 2 point charges Q1 and Q2 at rest in vacuum and separated by a distance R1, which is shows in a diagram. We have two positive charges, charge Q1 and Q2, separated by a distance R. What the statement of Coulomb's law? The Coulomb's law states that the electrostatic force is directly proportional to the product of magnitude of the 2 point charges and is inversely proportional to the square of the distance between that 2 point charges. What it means that the force, which is either attractive or repulsive, will depend on the magnitude of point charges and inversely proportional to the square of distance between them. If we write in an equation, it becomes F21 equals to K Q1 Q2 upon R square, where R12 is a unit factor which directed from the charge Q1 to Q2 and K is a proportionality constant. The force on the charge Q2 exerted by the charge Q1 always lies along the line joining the two charges. R12, it is a unit vector. The meaning of unit vector is that the magnitude of that vector is 1. The rule is say that the similar charges will repel each other while the opposite charges will attract each other. If we work on a SI unit, the value of K is 1 upon 4 pi epsilon naught and its value is 9 into 10 to the power 9 Newton meter square coulombs की power -2. Here epsilon naught is the permeability of free space or vacuum and the value of epsilon naught is 8.85 into 10 to the power -12. Again, if we go further, the magnitude of electrostatic force between the two charges, each of 1 coulomb, are separated by a distance of 1 meter. It is a huge quantity. We measure in microcoulomb and nanocoulomb. We also remember that sometimes the vacuum is not there. There is the epsilon naught. In that case, we use the relation. So what we can say that the Coulomb's law has the same structure as the Newton's law of gravitation, both the inversely proportional to the square of the distance between the particles. The electrostatic force is directly proportional to the product of magnitude of 2 point charges and gravitational force is directly proportional to product of two masses. In gravitational force, we're using the gravitational constant. The value of gravitational constant is 6.6 into 10 to the power -11. The value of constant K in the Coulomb's law is 9 into 10 to the power 9. So we can say there are some similarities between the gravitational force and the electrostatic force, but there are some differences also. Just like the electrostatic force may be repulsive and may be attractive, it depends on the nature of charges. If there are the opposite charges, they will repel they will attract each other. And if there are similar charges, they will repel each other. But if we're talking about the gravitational force is always attractive in nature. That is a formula of Coulomb force 1 upon 4 pi epsilon naught Q1 Q2 upon R square. This is the vector form of electrostatic force. The expression of Coulomb force is true only for the point charges. However, we can apply the Coulomb's law for the two charges or also. So what we can say that the Coulomb force can be calculated in that way. This is the example how we calculate the force between two charges Q1 and Q2. Here we have considered a different value of Q1 and Q2. The distances are and we are going to calculate the force in a different cases and we also can denote the nature of the force. It is positive, negative, attractive or repulsive.